So you've got Isaac Sim installed. Now what's next? Here are my suggestions on some good resources and some cool features in the UI that'll help you get started. Let's start off by making sure I've got the two important editors installed, that is Cursor and Visual Studio Code. Cursor is great for AI assistance. Okay, so next, the Getting Started tutorials. You've got two of them. Quick Start with Isaac Sim. It's just a very basic one which just takes you through building some basic prims like a box and so on, and just gets you familiar with the physics and collision properties. And I would go ahead and do all three workflows. So there's a GUI, so you're just interacting with a GUI as you see here. And then there's also the extension and standalone Python. And both of those just use code to achieve the same thing. I'd say it's definitely worth doing all three workflows and getting a feel of how each one works in its own way. And then I'd move on to Quick Start with a robot. And this one just allows you to import your Franca Panda arm and manipulate it a little bit, super quick, but it gives you a bit of an idea how robots work. And again, I do the extension and standalone Python versions as well. And then I just scan through the rest of the Getting Started section here. Now there's a series of great short tutorials that are kind of difficult to find, but I'll leave a link. So you'll go to Nvidia On Demand. And then once you're in there, you will search for Kit 104, and it's kind of split up. You'll have to jump around, but you'll be able to find them. And if we just look at what's covered, so in the beginning, part 1 and 2, just the basic navigation basics, and then parts 3 to 7, rigid body physics, and then parts 8 to 10 will be friction restitution, and 14 to 17, all the various different joints, and then 18 and 19, deformables, 20 and 21, some particle deformables, two pretty cool demos there. And then 23 and 22, not as interesting, but worth watching. And they're all done by this instructor who has a very pleasant teaching style. And I would suggest to actually go through each of those examples in your UI and follow them. There's a lot to be learned there. Next up, I'd move over to the Core API tutorial series, which at the moment is under Tools and Tutorials and Python Scripting. Here we've got 7 tutorials, each one 10 to 25 minutes long, although maybe just give a little bit more time to take your time and understand them properly. So if we look at the first one, we just create some basic prims like a cube. Then we're going to move on to creating our first robot, or rather importing our first little robot, which is a little wheeled robot. Then we're going to add a controller to that same wheeled robot so we can manipulate it with our keyboard. And then we are going to add the manipulator robot here, this Franca Panda arm. And then we're going to combine both those robots together on the same scene, which is a little wheeled one and our arm. And then we are going to add a task where the little robot brings in a block and then the arm picks up the block. And then lastly, it's data logging. But each one is just around a half hour. And I think they explain some of the basic concepts really well, and they're quite fun to do. Okay, so next I'd go to help and physics examples. And here we've got a lot of content which will give us an idea of how everything's put together. So let's go ahead and click on box on a table and we can see our simplest example. And there, if we click on play, we can see the box falls, it spins, and then it falls. So let's just do a little bit of investigation here. Let's go ahead and look on the right, and let's click on, let's go ahead and find our box actor. There we go, and we see the properties panel down the bottom right, and we can see the whole geometry and the mesh that's it's built out of, and we can see under physics, when we go ahead and we run it, we do see it spins there. Let's see why does it spin, or let's see if we can stop that spinning. So we can see under rigid body, the max angular velocity. Let's see if we can perhaps zero that out and see if that actually does anything. So we double click on that and we change that to 0. Okay, now if we run it, we see it just falls directly down. So we know, okay, that's what's causing it to spin. So we've learned something now. And then we can go on to the next physics example, which is 2 boxes on a table. Let's do a bit of investigation here. We can see this one has got a parent X form, which is our compound rigid, and that's where the rigid body has been assigned. And then we see the individual boxes below, that's where our collider is assigned. Okay, so let's just see what does this do when we actually run it, and which one's responsible for gravity and which one's responsible for hitting another object. So we're deleting our rigid body, which is on the parent X form, and we click play and we can see it doesn't fall anymore. So we can say, okay, our rigid body is connected to gravity. Let's go and add that rigid body back. So we'll Control Z, and now we run it. Okay, so we've got our gravity back. So let's dig into the individual cubes, and we can see on our cubes we've got colliders on both. So let's see what happens if we delete our colliders. So I'm deleting the one collider and then delete the other collider. Now let's push play, and we see it doesn't actually hit the table. So we can deduce that the collider is what makes it actually hit into the table. So we know what causes the gravity and what causes the collider, and we've done that just by investigating. Okay, cool. So now we're moving on to the next scene, which is the various shapes on a table. Now here, let's go ahead and click on open source there. As you've seen, that actually opens the source code that creates the scene. And if we open that in Visual Studio Code, we can see it's very nicely commented. So we can see there's an individual section for each object that's created. So there's the USD API being used for the box. And below we can see there's the code for the sphere. And we can see there's the code for the capsule and so on. And a little bit later, I'll show you how we can actually run that code within the UI. And those are just a few of the basic ones. Then we can move on to rigid bodies. We see we've got center of mass and force and all of those displayed really nicely with some really nice basic scenes and the code to go along with them. And for our materials, we've got material density and friction and restitution, also really nicely displayed in each of those environments. Every one of the joints with its own scene, and we can go and fiddle around with the properties on those and learn how the joints work. Same for articulations, and if we go right to the bottom under complex showcases, there's some really cool stuff in there. So my advice would be to spend a lot of time in this section, just go into each of the showcases, specifically the ones that interest you, break them down, expand the stages, look at each of the objects, look at each of the properties, start to wonder why do specific objects do specific things, and go and see if you can change those behaviors by finding the properties that are responsible for them. And I would just go ahead and just specifically find what interests you, especially in the complex showcases. Just go and see how those are built, what they're made up of. Now, next up, I'd install nvtop, and that's just a nice graphical interface to show us what our GPU and memory use on the GPU is doing, and it gives us a nice little graph. It's maybe something trivial, but for me, I like to be able to see which of the scenes are straining my GPU and memory, so I think it's definitely something worth installing. And next, if we go to Help, and we go to the scripting manual, we can see some of the commands that we can use to add various objects to the scene. So let's just go to the core, and let's go to Objects, and let's find a visual cuboid, which is just going to be our cube. And let's just take this little bit of code here. Let's copy that. And we're going to run that in the UI. And you can see I've opened up the script editor on the right. You'll just go to Windows Script Editor. And that allows us to run code within the UI. And we can go ahead and let's just add a flat grid so our environment just looks a little bit more complete. And now we can go ahead and run the code. We can see it'll add a cube for us. Just as if we'd manually added it, it adds it for us just with the code. If you'd done some of those tutorials earlier on, you would have seen how all of that works. But if you haven't, that's it in action. And what we can also do is that is using the core API that Omniverse has created. We can also go ahead and let's just open up our physics examples, and let's look at the USD code that would have done the same thing. So we're going to open up box on a table, and let's look at the code for that specifically, and we can copy that code. Might have to just make one or two little edits to that code so it'll run in the little window editor. There we go. And I'm going to make one or two little changes just so it does run properly, just so the right objects are being referenced. So I'll go to my script editor, add another tab, paste that code in. I'm just going to remove some of my comments quickly. And we can see this is pretty much going to do the same thing. It uses a lot more code to do the same thing because it's raw USD, and we run, and there we go. It creates us a cube. Now let me just explain the difference between the two. And we can see under the core API overview, we can see there's an explanation of what it is. So it says the core API is a wrapper, and here's an example of adding a cube just with raw USD. And then here is the dynamic cuboid function that does the same thing. So it's just less code. Either way, whichever you use, you can pretty much achieve the same thing. Although from what I've seen using the raw USD, you've got a bit more configurability. Okay, now onto a really cool feature. If you go to the commands panel, just going to window commands and activate that, we can see we can actually record commands and then put them back into the script editor. So let me show you a little example. Let's go ahead and add a cube. And now we can go to the commands panel and see what is the code that was created to add the cube. So we've got the cube there. And if we go across to commands, we can see we click on the one where we created the prim. And if we go ahead and copy selected commands and we go back to the script editor and paste that in, we can see that's the actual command that would create the cube. And if we click on it, it reruns it. Basically, if we want a reference to what code will do what action, all we need to do is go and do that action in the UI and then see the code it creates. I'd also head over to forums.developer.nvidia.com, and you can see there you can filter via Omniverse and then Isaac Sim. And then once you're in Isaac Sim, you've got all sorts of tags there. So if you're having errors or installation issues, or you want to look up something specific about collision or joints, there's some pretty good stuff in here. I'd also join the Nvidia Omniverse Discord, and very similar types of channels there, various different discussions going on, and also quite nice. You can click on the events and see the events that are happening. Like for example, there's a repeating Wednesday OpenUSD study group discussion, and Isaac Sim and Isaac Lab study group every Wednesday as well. And then the various different office hour events will be posted here as well. As for YouTube channels I would subscribe to the Nvidia Omniverse one, and specifically one of the playlists that I found very useful. If you go right to the bottom, we can see Nvidia Omniverse Essentials. There are a lot of videos here, 158, and you kind of have to scan through them and see which ones are useful to you. But there's a lot of really good content in here to do with USD and how to connect Omniverse with the various other packages like Blender, Unreal Engine. Some of this content is quite old, like going back to 4 years ago, but I'd say the fundamentals still apply, and I would just scan through these and see which ones are of interest. Next, I would go to Lychee AI. He's got some really, really good content here, and he also posts very regularly. You can see just in the last month, there's 3 or 4 videos here. I would go to Taser Technical. There are only 2 videos so far referencing Isaac Sim, but they're really, really good videos, and he is really, really entertaining to listen to. So if he carries on like this, there should be a couple more, but I would really highly recommend his channel. Very, very entertaining. Robot Mania, also another really nice channel. And lastly, I would go to the Deep Learning Institute, and I'd click on the self-paced courses, and I would go to graphics and simulation. And there's a lot of really good content in there. Some of the ones that I've really enjoyed is this how to build an OpenUSD application for industrial digital twins. The fundamentals of working with OpenUSD to me is quite foundational, as is this learn OpenUSD and learning about the stages, prims, and attributes. This one, getting started, simulating your first robot, and also developing an Omniverse kit-based application. Okay, so that's everything for this video. Thanks for watching. And if you enjoyed this content, please consider liking or subscribing. See you in the next one.